Graphene by TeamAwesome. Graphene can be described as a single atomic layer of graphite. It consists of several very tightly bonded carbon atoms organized into a hexagonal lattice. Its stability is due to these tightly packed atoms and its sp2 orbital hybridization. The hexagonal structure allows for more stability because when the graphene is exposed to any carbon molecules, the graphene can self-repair holes in its sheets. In graphene, each carbon forms 3 sigma bonds between 3 other carbon atoms via the sp2 hybridized orbitals. The last available electrons make pi bonds to hold it together. Sheets of graphene can be held together by van der Waals bonds, but graphene is only created if the carbon hexagonal stacks perfectly line up on top of each other. Knowing the properties of graphene and its tremendous bond strength, we have created a theoretical graph. This graph shows electric properties and its ability to retain its initial size after strain, which makes graphene an excellent conductor of heat. Graphene is found in the phase diagram for carbon in the graphite region. Graphene is a metastable phase that doesn't need to coexist with other phases. Graphene was first isolated from bulk graphite with the use of sellotape to peel away layers of graphite. This is known as exfoliation but cannot be mass-produced. The most promising way to synthesize single crystals of graphene is chemical vapor deposition, or CVD. CVD works by making gaseous carbon molecules come into contact with a hot substrate where the graphene forms. Under high heat, sections of graphene could come loose and rotate. As graphene cools, the rotated sections link back up with the lattice in an irregular way, which is why we get these flowers. The lattice is already stronger than steel, but defects might allow it a little flexibility, making it even more resilient to tearing or fracturing. Researchers should be able to correlate the appearance of these defects with variations in growth conditions, which should make it possible to either avoid or produce them at will. Thanks for watching our video, and we hope you enjoyed.